first determine the vertex. What is the vertex of this, if you don't mind telling me?
That would be -4 comma -1.
Yeah, so -4, -1. So we can at least put a dot there. Yeah, we got a dot there. And then we build a table here, X and Y, -4, -1. Two smaller, two larger. Now, we talked about jumps and gaps and stuff like that, but that's only if you got a weird thing out in front here. So really from here, it's just about putting this into this correctly. And I mean, I know that that could be the area where some issues occur. -3 plus 4 is 1. So it's 1 squared. And then you negate it. You square before negating. So it ends up being -1 minus 1, which is -2. And by symmetry, this is also -2. Is that okay?
Yeah.
Is that different than what you have?
Yeah.
Because that is likely where the error occurred.
Yeah, I think I've got like -6 and -2 for the x-intercept.
We're going to get
Actually,
to
wait,
that.
no, that was
We're yeah,
wait, that
we
was
will absolutely
some
get to that.
of the um I found, yeah, I think I got the same vertex for it,
I'm just
but
talking about the graph. Does the
yeah,
graph
the graph seems to start to look kind of like I think that's what kind of what it did, yeah.
Okay, so the next one here, -2, we put that in for x. So -2 plus 4 squared minus 1. -2 plus 4 is 2 squared. That's 4, then you negate it. -1 gives you -5. So you got to be able to fill in the table here. There is, like I said, there's another way to do it. Depends on your comfort level with that. But there you go. All right.
Got it.
Um,
But then
so
wait, so you plugged in the one of the y values, one of the x values,
you
or you plug in the
you
y,
you always put
one of
the
the
X
y
value in.
values,
Always put the X value in.
the x value and
Always
the
the X value.
right, yeah. I was wondering how she got the -2. Now I understand how she got the -2. So I think that she did it the same way that you did it here.
Definitely not
Um,
-29, unless this is a cube, and we don't know that.
yeah, so it would be, yes, -2, then two squares. Got it.
Okay, so now that you have the graph, this helps. It doesn't actually answer the other question, it just helps. The h of 0, this means, and this is where a lot of students really struggle. This means to put 0 in for x.
So that means you plug in x for
Yeah,
in 0 for x.
-0 plus 4 squared -1, like this. Why don't you try simplifying that for us, please?
I got -17.
Okay,
You
that
want
is
me to?
correct. So the answer here is that h of 0 equals -17. What is that? It is the y-intercept. It is where it crosses the y-axis.
Got it.
Okay, now the other one that is often confused with that is what this is over here. This is setting the equation equal to 0. So in
Got
your
it. I
case,
think
it's 0.
that's what I'm struggling with more, like the setting equal to 0 and finding that. I can be a little bit better at it with a little bit of practice, but sometimes make a little bit errors there. Since to find, so you would have to find factored form, wouldn't you, for the
Well, hang on a
find the
second, because
x-intercept?
this you've got to know the geometric meaning, which is the x-intercept, where it crosses the x-axis.
Yeah.
So let's go back and look at the graph. Does it cross the
Oh,
x-axis?
No.
So there are none. Now let's look at it and see why when we go to solve it. That's because that's a important thing here. It's important to be able to know, well, why, like, if we didn't have the graph, does this work? Not work. So let me grab this, go down here. So the first thing you do to solve this is you would add 1 to both sides. And you have 1 equals negative x plus 4 squared. And then you would divide both sides by -1. Get that? And it's -1 equals x plus 4 squared, like this. Now you would take a
Like
square
square root
root
of
of both. And this is the problem. In the real domain, which is where you're working in, they don't tell you that, but you're in the real domain, the square root of -1 is undefined. So this is not possible.
got it.
Yeah, you might be like, well, why isn't it possible? Well, it is, but not in the real domain. In the complex domain, it is, and maybe you'll get to that here. Well, you will get to that here, but for right now, so that's why.
Got it.
Right. So that is everything for this problem. So you are welcome to send over another one. Gonna step away for 30 seconds, but go ahead and drop something in the chat there, and we'll get started on the next one here. All right, I am back. Let me know if you got another question you want us to look at.
Here's like
I can also make some up if needed.
so it's in the chat. Next question. This one's the
Ah,
fencing
yeah.
problem.
Yeah, remember this had a certain format, so probably have to remind me of what to do.
Yeah,
Um,
so this one's the one of the part of the fencing questions we're solving. It's the where we have to like draw like a sketch of it on the top right.
so I
So
hear I hear hear you on that. It's they say they'll use 800 feet of rope to create a rectangle and then 6 parallel partitions. Okay, so that means that there's 6 here. Let me see here if I do one. How do I do this here? One. That's that's not going to work. Let's see here. I didn't quite get enough. So these are not the scale. Let's see here. See if I can add one there. One, two, three, four, five. The drawing doesn't need to be that good, but I mean, we don't want to be terrible. So there you go. There's one, two, three, four, five, 6 partitions, creating seven rooms like that. Okay. Is that okay?
yeah,
All right. Now, and they say the thing is, I probably should have done this It doesn't really matter, but I guess you could also draw it the other way where the partitions are going horizontally. You may find that you like sort of the solving of it one way versus another. One, two, three, four, five, six. Okay. Like, because this way is X and then this way is Y.
Got it.
Like that might be because when you start writing an equation here, it's well, the area is X times Y, but the perimeter, not really the perimeter, the rope equation, which is 800 feet of rope, it's better to use, we typically like X to have the coefficient in front of it. It's 2Y plus 1, 2, 3, 4, 5, 6, 7, 8 X, and you could solve that. You'd solve that for Y.
Got it.
So we got we've got to
Right.
solve this for Y. So it's 800 minus 8x divided by 2, y equals 400 minus 4x, like that. So then to solve this,
Wait,
and I don't remember,
wouldn't it be 800 plus 8x divided by 2?
you're moving the 8x to the other side of the
Oh, so that
equation.
becomes negative.
Yeah.
And then dividing, oh yeah, yeah, no, no, no,
Okay, good question because we got to get this right. So your area is x times y. Y is 400 minus 4x. And I don't remember, you doing these by hand or are you graphing them on a calculator? What are you guys doing?
I think it's by, I don't think she was having us graph it. I think just finding the y of the vertex, or
Yeah, so
the,
this has got it goes up, it goes down. Its area though, and the x value, that's minus 4x squared plus 400x. Why don't you calculate that vertex point for us, please? However you plan to do it, technology, by hand, otherwise. How are you doing on this one?
Um, um, and I found actually I got the x of the vertex with
Okay. What did you get for that?
for the x of the vertex, I got 50. For the y, it would be I got 10,000 for the y.
I agree. All right, so the x value is the actual x, but y in this case is the area. The area is the 10,000.
So it would be 10,000 feet squared.
Yes, yes, very good. And I don't remember what the,
Yeah, I think that was just the sentence for the final answer. Like what are but asking for the outside dimension with the maximum areas. So
so now we need to find the y value. We
yeah,
know the x, to find the y, meaning the y here, we have to put that back into the 400 minus 4x. 400 minus 4 times 50 ends up being
be
200.
200. Mm, wait, would you plug it into the middle topic vision? The one for
One.
row?
You're solving for y. Y is the vertical.
So you plug it into the equation that you got simplified there.
You could put it into the rope equation. You could put it into the area equation, but go for the one that is easiest, the one that's already solved for.
Got it.
All right, so while you're working on the next question to bring up, I'm gonna just grab my coffee, be back in 30 seconds or less. Back here.
All right, so have that switched on. Oh, I think this. I have a question. Actually, let me screenshot the structure. This one's on more completing the square. Um, Specifically, I wanted to go over number 27 in this screenshot. So, yeah.
So these are the two questions here. You want to do them both or just the one?
Just number 27. I think number 28. I got that.
Okay. I gotta re-snip this. Be right back with you. All right. So this completing the square business really, I mean, it's pretty tedious, but it is necessary to do. So you do have to complete the square. Um, the way to do this is to first move the constant to the other side of the equation.
Okay.
All right. And then the next thing, because there's a number out in front besides one, is you factor it out. So 1/5. And
So it
this is
has to be
hard from a,
one, and it can't be like -1 or anything like that.
yeah, you really don't want to. And I know what's hard is to figure out this number right here. The way to do it is to figure out, well, what do I put there when I take 1/5 of it? Do I get back to this number?
Yeah, that's what I was kind of struggling when I did this. Because I put 2x instead of 50x.
Right. And that's where you got to multiply in and decide if you get
So
back
you
to
have
the
to
previous line.
multiply the 1/5 by
Yes.
10.
Well, okay, you gotta be careful. You gotta be careful. Like I try not to remember is it divide or multiply because it will mess you up. It does when you distribute this 1/5 in, does it get you back to this previous line? These lines are
Got it.
equivalent. They're all equivalent.
So it isn't
And
like you
equi
multiply by the
no,
denominator or anything like that.
you actually divide by the number.
But when it's a fraction, would you multiply it by the
You divide by the number. 10 divided by 1/5 is 50 because you multiply by the reciprocal.
uh
Yeah. So you're always dividing. But I try not to remember rules like that because then it's like confusing. I mean, there's only so much that we can handle.
Got it. And then in this case, you would put 1/5
So now
and
we got to figure out, from here you probably got it, but it's half of the 25, half of the 50, which is 25 that you divide by two, but
yeah,
then you have to square it.
yeah. So then,
And that's a big number,
yeah,
but you are taking a fifth of it.
yeah. So then when you multiply it by you have to multiply the 625 by the 1/5, then add it to both sides, or add it to the
This
side with
this
the
becomes
full.
1/5 of 625 is 125. That is what goes on both sides. And I
Yeah.
didn't put the box in, but that really is what you're looking for there. Then you bring the 1/5 down.
Wait, would you subtract 125 on both
No,
sides or
no,
add it on both sides?
you, you add it. You add it.
Or yeah, got it. And then at the bottom, at that, then you do and then at the bottom you would do minus 129 on both sides to bring the 129 over, right?
Yeah. So it ends up being 1/5 x plus 25 squared minus 129. And that's when you bring back the whole whatever letter, h of x in this case. You just bring it down like that.
Got it. Yeah, I think I get it now. I think I just got confused with the 50 in the middle. That kind of messes it up because then if you don't get 50 there, then you kind of get the wrong half. And then yeah, I think that's what I got wrong. That one.
Right. You want me to make one up like this? Do you got another one for us to look at? What would be best? We got to get this completing the square down. You're getting the hard ones. You really got to know how to do them all without question.
Yeah, maybe a little more practice with completing the square
All right.
with
So you want me to come
fractions
up
and
with one here?
specific. Yeah, with fractions and like stuff in front of like other than one
Yeah.
for a. I'll just
Yeah.
do
Let's do like 1/3 x squared plus 8 x minus 7. It's kind of like the last one. Then I can make it more difficult. But give this one a try on your own, please. And if you have questions, please ask along the way to check steps if you're unsure.
All right, I got 1/3 x time in parentheses x plus 12 squared minus 11.
Okay. I don't know about that last number there. Wait, no, because let me see here. Let me just so we have 1/3 x squared plus 8x, and then whoa, I haven't done that in a while. All right, 1/3 x squared plus 24x, leave a space. So you put plus 144 in here,
No, I put what? Oh, actually, wait.
and then it goes back to being 48.
Oh, I put plus 12 there too and multiplied plus 12 by one. I forgot that you had to square it when you put it back up there.
Yeah, you have to square it to go backwards.
Yeah, I didn't square it, and that's why I got a different. I didn't get um 0 for that. So if I were to do it in 12,
So that means you're adding 48 to both sides, and then you subtract it back over.
yeah, so 48, 48, then that would be that'd be 55, and then yeah, 55, and then minus 55, minus 55. Yeah, so it'd be minus 55, not minus 11. Yeah, I think it's just the squaring the half of the middle term thing like that.
So let's do another one here. I'm going to throw, if you're okay with that, I'm going to throw a negative in front though. That does affect the middle number there, um, like that there. So it will affect this one, the sign of this when you factor out that negative. So keep that in mind here. Give this one a try, please.
All right, I got negative 1/4 10 in parentheses x minus 6 squared minus 7.
Okay, that sounds pretty good here. So that puts you at a 36 here,
Yeah,
minus 9, minus 9, minus 9, which is -7. So then you add 7 to both sides. Okay, good. You have some other stuff you
let me take actually it's like a working. All right, yeah. All right, so 2.6. So, 2.6 is the quadratic regression lesson.
okay? That's definitely a calculator thing you'll see on that part of the test. We can maybe quickly do some calculator stuff.
Uh, Pretty much the bad thing is that pretty much I think it was because of the equation. It got the wrong equations, but we it's just kind of so this is number two. The whole thing's number two.
Okay,
So
take
we
a look
pretty
here.
actually yeah. So I got a lot of this one question wrong.
Yeah, I mean this is a complete calculator question. You have a TI 83, 84 that you're using.
Yeah,
Okay. So we can certainly do this. I've got a virtual TI 83, 84 I can put up here. Did you get part A correct?
part A was not correct. I put 1.4118x was 46. And when you
Okay.
showed us the correct answer, it was something totally different.
So one of the things here is that it says that X years since 1980. So the year is actually 4, 8, 12, 14, 18,
Yeah, I think I
22.
wrote that down. Yeah, I put the 4, 8, 12, 14, 16, 22, 26. Go.
So in L1
Yeah.
and L2, you're putting your X
Oh, wait,
and your Y value.
actually for 1998, I put 16.
Yeah, I don't know why they jumped, but they did. They whatever. We can't.
Yeah, yeah, I put 16. I got it off a little bit.
All right, so I got a virtual T83 up here. You go to stat, edit, and then if you have data in your L1, you can hit clear and enter, and it'll clear everything out. You got to just get this data into the there. Most of the mistakes are made by entering it incorrectly, which is kind of what I just heard. It happens. You
Yeah,
you just want to
I
double.
think not. I think I kind of assumed there was like a pattern between like a difference or like a delta between them that was the same. That's why I kind of like just jumped from the 1984 to 1988 with the same jump from 1992.
And
But
I
yeah, I
wish
think
I
that
wish that I mean, this is just the nature of these. You have to do them. You have to get the data in correctly. It's all on you like that. So you're seeing my screen, get that data incorrectly. L1 into L2
all
second
right.
quit.
So L1 is
It's
gonna
under
be
stat edit. Yeah.
4. So edit and 4, 8, 12, 14, 18, 22, 26. All right, and then 49, 64, 72, and 80. All right, yeah, now I got the correct
All right, so I always quit out of
order.
here, kind of like going back to your home screen, quit. You go back to stat, calc this time, and then you go down to lin reg. So stat,
Calc,
calc,
then,
lin reg,
yeah,
and hit enter. Yours might come up with a screen for like L1 and L, or, X is L1, Y is L2. But you should ultimately get something like this with your,
all right, so
let me know if you see
calculate.
something like that on there.
Yeah, I got it.
Okay, so I'm gonna go to the other screen for the moment. Um, when you write out your equation, it has to tell you how many decimal places. It says four here. You have to say, okay, four decimal places. So that means it's y equals 0.7115 x plus 58.0330, like that. And that's your equation. Now, they don't want it that way though. They want it as CL as a function of X years. So you really want to do it as CL equals 0.7115X plus 58.0330, like that.
Wait, wouldn't it be CL in parentheses a function of X? Or would it just be a CL?
The way that they're writing this, I don't know. It's weird notation, subscript notation.
Got it. I think with that she just wanted us to like know how to properly name it.
Okay. Now you'll notice
Yeah.
on yours, it probably has an R and an R squared value. The reason
Yeah,
mine doesn't is I didn't set the diagnostic on, which I can if we really needed to, but you'll want to fill that in there.
got it. Yeah. Now that I have the correct points,
Yeah, you should be able to move through
yeah,
the rest of it pretty easily
yeah. I
with
think
that.
it's
So
all about
always,
like accurately putting in the data then because
yes,
most of this is calculators, so it
yeah,
starts off with putting in the right data because then that automatically makes everything else kind of wrong if it's like that because
all right,
everything's dependent on either that question and the one
yeah.
other than. Yeah. And the last question is just asking like the comparing basis what both of the R squared values. And wouldn't it be that if it's closer to one, it's more accurate, it's a better fit for the data than if it's
Further from
yeah,
one.
if it's further from one, and then if it's closer to one, then it's not a good fit. So for R squared, wouldn't it be if it's like if R squared equals one, wouldn't it be like a perfect fit?
Exactly. Exactly.
Got it. And then if
All right,
it equals
we do have to
zero,
stop here for